Good afternoon, everybody, and welcome to this Net Zero live session on the housing crisis and how we create net zero new homes. I'm Joey Gardner, I'm contributing editor at Building and Housing Today magazine, and I'll be chairing the session designed to understand whether traditional house building methods are holding back the zero carbon agenda. In many ways, this session couldn't be more timely. The publication earlier this year of the government's roadmap for energy efficiency standards in building regulations for new build homes, also known as the Future Home Standard, now we finally have an idea what direction the industry is headed in. From this year, the consultation has said the government will have to reduce carbon emissions, or the industry rather, will have to reduce carbon emissions on new build homes by 31% on prior standards. And from 2025, new homes will all have to be zero carbon ready, able to become net zero at the point at which the electricity grid decarbonises. This all means the phasing out of gas boilers entirely, alongside the installation of renewables as standard, and further increases in as-built fabric energy efficiency. At the same time, the failure of the Green Deal has only served to highlight the scale of retrofit challenge the UK is facing, and last week's decision by the government to sign up to the Climate Change Committee's target for 78% reduction in carbon emissions by 2035 just highlights how quick this change will all have to be. Now, at the same time, there's a huge drive in the industry to modernise methods of construction, which is seen by many as absolutely essential if we're going to reliably deliver on these targets that have been set out. So today we can start to look at how ready the industry is for all of this, and whether traditional brick and block construction is perhaps now a barrier to delivering the uptake in standards that is necessary. Now, we've got a great panel to discuss all this. I'm going to ask them to come forward and introduce themselves and outline their perspective, after which I'll take all your audience questions and share a Q&A. So hopefully we're going to get a great discussion going on this subject. Everyone should use the video conferencing system while the presentations are ongoing to put down any burning questions as we're going along. Now, first up, we've got James Mills, who's product manager at Rockwool UK, and I think he's going to put forward a presentation making the case perhaps for looking at changing the way that we build. Over to you, James.
Thanks very much, Joey. So absolutely, my name's James Mills. I'm a product manager at Rockwool UK, and we're very proud to be sponsoring this webinar based on the critical topic of achieving net zero in housing. And I think just to kick things off, I'd like to sort of take the opportunity to run through a couple of slides that will kind of set the scene and explain why we've initiated this discussion. So starting off, I'd like to talk a little bit about who Rockwool are and why this is such an important topic to us. I'm sure that everybody in the construction industry will be well aware of the name. We're the world's leading manufacturer of stone wool. And actually we produce quite a broad portfolio of products for both the construction industry, but also other solutions that will help us to address climate change and put forward solutions that will enable us to get through this. So you can see on the screen there that we produce a whole range of products from building insulation, non-combustible facade cladding, acoustic ceilings and partitions, and also things like water management solutions, so soilless grow mediums that will help with water scarcity, and also flood defence systems whereby we can put in stone wool products into the foundations of buildings that will allow flash flooding to be absorbed by our product and slowly dissipated out to help manage issues where we have instances of flash flooding. And so why Rockwool stone wool? Why do we pursue stone wool? You know, we are really pioneers of stone wool, and we see it as a magical material. It's a naturally occurring, abundant material. Our raw material is basalt rock, a volcanic rock which is infinitely recyclable. What we're looking to do with that material is really harness the power of stone and combine it with the insulating properties of wool, and it brings a number of benefits. So whilst very much what we'll be thinking about on a lot of the topics we're talking about here is thermal efficiency and reducing carbon emissions, we're also conscious that there are a lot of other considerations that industry needs to think about when achieving net zero buildings. And the power of stone wool means that we can bring a lot of other benefits outside of just thermal performance, including things like non-combustibility, acoustics, sustainability, longevity, versatility, water properties. Our product is hugely versatile, hugely sustainable, and massively suitable to help us drive forward this agenda of net zero. And in fact, as a company ourselves, we're very conscious of our own footprint and impact. And you can see on the screen there that we're a carbon negative organisation. Our insulation products themselves save 100 times the amount of carbon emitted in their production. We contribute to 10 out of the 17 UN SDG goals. And we've also just recently announced some very ambitious science-based target initiative reduction. So we're going to be reducing our factory GHG emissions by 38% by 2034 versus 19 levels. And we'll also cut non-factory GHG emissions by 20% in that same time period. So we're very much about enriching modern living and enable us to tackle these challenges that climate change are bringing. So I think to take a little step back and have a look at what is the situation and what's driving this need for us. I think it's fair to say that it's fully recognised that global warming is very much a real thing. The 2015 Paris Agreement committed nations to remain under a 2% global temperature increase, but we know that we're already at about 1.2 degrees increase annually globally, and that's creating substantial impacts and problems across the planet. We also know from modelling that should we see that 1.2 grow to 1.5 or more, we will see exponentially worse impacts of that. And in fact, if we don't put in place some serious carbon reduction programs, our trajectory means we would be on course to reach 2.8% increase by the end of the century, which would be literally catastrophic. You know, we need to be hitting net zero by 2050 in order to stay under 2 and really get to 1.5, which is really what we could possibly manage and tolerate. When we look at how that filters down from a sort of planet and global position, we know that the UK government recently has come out and committed to some very aggressive targets, talking about reductions of 78% by 2035 versus 1990 levels. And we know that we've already managed a reduction of 42%. And in that meantime, we have an interim target of 68% for 2030. You know, something we're very conscious of is that there's some low-hanging fruit in order to reduce carbon emissions, and it's going to get tougher and tougher. And we really need to take a look at the impact of buildings and how we're going to really address that, because not a lot of the carbon reduction that we're seeing is a result of higher energy efficiency buildings. If we look at the top right-hand corner of the slide that's on the screen there, we can see that building and construction alone represents 39% of global carbon emissions, and housing would represent approximately half of that. And breaking that down a little bit further, it's very important to recognise that of that 39%, 28% is operational in-use energy emissions. But there is also the embodied carbon going that looks about the materials that go into producing these houses and buildings, and that represents 11%. So both embodied and operational carbon needs to be very closely assessed. So that's kind of the background in terms of the global position, what we see in the UK, how it impacts housing and where we're at with that. And I think how then do we address this? And the government is making strides forward with the Future Homes Standard. We've recently learned that the target's going to be a 31% reduction in carbon dioxide emissions. And we've seen that the Fabric Energy Efficiency Standard, FEES, is going to be retained in regulations. And I think that's been very well received by industry, because I think it's well recognised that the starting point for high energy efficiency buildings is a highly effective, thermally efficient fabric. The second element of the Future Home Standard will really push things further forward, and what we're looking for there is low carbon heating systems to be introduced, along with very high levels of energy efficiency in the fabric. So targeting 75 to 80% reduction versus what we see today. A big move is going to be that no new homes will then be connected to the gas network. And so what that's going to mean is that we're going to need significant improvements to insulation and air tightness, which will allow electric heat pump systems which have a lower output but can be net zero. When we get our grid to fully renewable, that will allow those technologies to provide net zero heating. This is going to come with some challenges such as overheating in buildings, and we need to be thinking about that. And also one thing to note is that actually local authorities are going to be able to set even higher standards than the ones that we've just looked through there. So coming on to some of the topics then that we wanted to discuss today, and you know, what are the limitations around traditional brick and block? Can we achieve net zero through this long-standing build method? You know, what we know is that wall thicknesses are going to need to achieve a minimum of 0.15 U value. To do that using traditional brick and block is going to mean a very thick wall footprint. And that has impact on either or both the internal space in a property, or from a developer's point of view, how many plots you might be able to get on a site. It's not necessarily going to be the most effective way to achieve those super low U values where you've got a 102 millimeter facing brick, 100 millimeter thick concrete block. They're not particularly effective thermally, and what we know is that they carry a huge amount of embodied carbon. So I would question whether this is going to be the best way to tackle the problem. I think another issue that we'll be talking about today is how we address existing homes. With 29 million existing homes in the UK, that's a huge housing stock that we need to deal with. What we know is that in 2020, 247,000 homes were built in England and Wales. And fantastic, if we can build these to new, more onerous regulations, that's great, but we've still got a massive gap to deal with the existing housing stock. I see another challenge in this as built performance, and you know, are buildings and houses achieving the performance that was calculated at the design stage? There's certainly studies to suggest anything from double, 5, 10 times higher energy uses than was originally calculated, and this is something we're very much going to need to be conscious of and address. So in summary, I think when we look at these issues and how we look towards achieving net zero, I think there's a whole host of things that go into this. So starting at the top, regulatory change. So changes to Part L and Part F of building regulations through the Future Home Standard is going to be critical for new homes. We're going to need government schemes to enable us to address the existing housing stock, and these schemes are going to need to be really well thought through, planned, and agreed with industry to make sure that the supply chain is there, the skill base is there, and that we can actually deliver these programs, because we've had a bumpy track with some of the recent initiatives announced by the government. I think further to that, industry itself needs to take responsibility. House builders and developers need to take responsibility, and a part of that will be educating the consumers themselves. It's well known that many house buyers are very unaware of the energy performance of their properties. They need to be more aware of that and what the impacts are. I believe personally that we need to start to look to embrace modern methods of construction much more, particularly in housing, you know, for the reasons I just covered, where we looked at brick and block construction and how that may not be the most efficient way. I think it's critical that we also assess not only in-use carbon emissions, but the actually embodied carbon that goes into building properties. And I think ultimately where we're going to see this big shift in reducing our carbon emissions in homes is when we can get electric heat pumps onto the majority of houses. And by 2025, as we said, every house will be required not to hook up to that gas network. And what we need is a highly efficient building fabric in order to enable the use of those lower output heat pumps. And finally, what I would like to say is that I think the use and development of things like EPD, environmental product declarations, that give you a very good idea of what goes into producing those products and what their embodied carbon is. Things like EPCs, energy performance certificates, which we know need a massive overhaul, and also digital tools like BIM, which are now enable us to fully understand what has gone into a building, and then how we can manage and improve and develop it into the future, knowing exactly what has gone into making up that house or building itself. So those are sort of some of the reasons why I think this is so important for Rockwool, what we can kind of offer to this challenge, and some of the key elements that I think we need to address. So yeah, with that, I would pass back to yourself, Joey.
That's fantastic. Thanks very, very much indeed, James, for that kind of great run through there of a lot of the challenges that are facing us all. And I think for the next speaker, one of the challenges you mentioned there was the retrofit challenge for the existing stock. And next up, we've got Joe Ragdale, who's Technical Director of Weatherby Building Systems, which is a supplier, as I understand it, of external wall insulation systems. So actually right at the cutting edge of this retrofit challenge. So Joe, I'm going to pass over to you to talk about, I guess, the challenges of fulfilling that agenda. Over to you, Joe.
Great stuff. Thank you, Joey. So Weatherby supply fully tested and certified external wall insulation systems. Our systems can achieve extremely low U values below 0.1. And our systems are fully fire tested as systems, not individual products. We have a number of options, A2 and A1 systems to BSEN 13501 available. We have a huge range of systems covering multiple substrates, insulants and finishes, including a range of brick slips, stone slips and render finishes. In terms of the projects we're involved in, we've always been strong in the refurbishment sector, working directly with councils and housing associations, various funding schemes to better insulate the UK's housing stock. We're extremely busy at the minute with high-rise installations, supplying A-rated systems to replace unsafe cladding. New build is also an extremely busy area for us at the minute, supplying a wide range of projects from schools, hotels, housing, commercial projects. Also specifically targeted modular builds, working with modular companies, providing modular specific systems, ideal for use in factories before pods are transported. So Weatherby are constantly developing new systems to offer improved solutions and to move with the market trends. Key aspects of systems include the speed of application, designing systems with minimal application times, reducing labour requirements, designing systems that are simple to install and reduce the need for skilled labour, especially in comparison with traditional builds. For example, our brick slip systems, the brick slips are installed like tiles, meaning we don't need bricklayers. We also look to provide long-term solutions, whether it be train and monitor applicators to ensure the right systems are installed correctly and they remain effective and durable over time. We have a range of 60-year systems available, 60-year life expectancy systems. And we now also have recycling schemes set up with all three of our insulations that we supply. Obviously, we're extremely busy at the minute, but the industry challenges that we're very much seeing at the minute, which we think will affect the industry's ability to meet the net zero challenges, are first off the funding streams. Properly run and audited funding streams allowing consistent funding, a workable model for the industry to insulate the UK housing stock. The Green Homes Voucher Scheme has limited success. It's now quietly being replaced by the LADs, the Local Authority Delivery Schemes, and Social Housing Decarbonisation Fund. Constantly turning the funding tap on and off is preventing installers and supply chains from forward planning and refurbishing properties on a larger, more consistent scale. Another problem we're already seeing is skilled labour in our industry. Our industry has become extremely busy with a combination of refurb, high-rise cladding replacement, and new build projects out there. Brexit and COVID has seen a lot of skilled labour leave the UK and return to Europe. The industry needs more trained and skilled installers who understand modern methods of construction, such as Weatherby render and brick slip systems. Labour shortages are already becoming a challenge for us in the industry. And finally, supply chain. Material availability, again, is becoming a big issue. Material prices are fluctuating hugely. For example, due to a shortage in raw material, cost of EPS has risen about 50% in the last couple of months. Galvanized steel prices and the availability is also starting to become a big problem for the industry. So we believe the lack of availability of material in volume will slow down the industry in 2021, and it will hold us back trying to reach these challenging goals. So I hope that was helpful. If I can pass back to you, Joey.
Perfect. Thanks very, very much, Joe. And a really interesting sense there, because very often the conversation about modern methods of construction is talked about solely in conjunction with the new build sector, but there was a sense from one installer of what modern methods of construction might mean for the retrofit challenge as well, and how that could start to play out, and of course, like everyone else, what the challenges are. Now, for the next conversation, or the next presentation rather, we're going to go to someone that is very, very much involved in the new build challenge. Nigel Banks is Director of Special Projects, as I understand, at Ilke Homes, which is one of the leading modular house builders in the UK that's really kind of come on strides in the last year. So I think his firm has kind of been leading in exploring ways to deliver net zero housing through modular construction. So I'll pass over to you, Nigel.
Thanks, Joey. Hopefully you can see my screen. So yeah, picking up on some of the points from the previous presentations, I think we established ourselves on the back of some of those issues around skill shortages, the availability of bricklayers and the need to build more homes. And one of the key things we've looked to do is build additional housing capacity in the UK. For those who aren't familiar with us as a business, we've got a very large factory based near Knaresborough in North Yorkshire. Currently employ around 500 directly employed employees at the business, and 95% of the roles don't require a trade background in the business. So we are bringing people from outside the construction industry to build houses using manufacturing methodologies rather than trade skills. We now have a team of land and development teams across the country that are looking at sites and doing full turnkey developments, and we now have sites of 200, 300, 400 homes that are exclusive using the Ilke Homes products, whereas we started off with smaller projects. So we've already delivered homes on 33 sites and have completed 5 zero carbon sites already. So I think part of my message today is it can be done. We have done it. The challenge is how do you do it cost effectively, and how do you make sure it can happen, and the point that James raised at the start around actual as-built performance. Going forward, we've got, as I said, some much bigger sites, more of a focus down in the southern aspects of the country, and also into Wales as well as we move forward. So this was Ilke Homes house number 1 and 2, the demonstrators that were done before the business was even created about 4 years ago, and built as zero carbon homes, all electric, heat pumps, solar PV, battery storage, EV charging. A lot of the technologies we're talking about now, we installed in the very first homes. It's been part of our sort of DNA from the outset of how do we make that happen, how do we get integrated into the house and into the manufacturing process such that it's easily manufacturable and in a cost-effective manner. So we learned a huge amount from those first homes ahead of embarking as a business and setting up our first factory 3 years ago. So we've done other sites. This project Gates Innovation Village was a really interesting one, where a home group of the client are now monitoring the site, and there's a number of different construction methodologies on that site. So they're comparing traditional build and modular and some panelized and some large format block built houses with a range of different electrical heating solutions as well. So some really interesting data will come out of that hopefully later this year from the monitoring of how those homes have performed and dealing with the performance gap issue, and getting a real understanding of some of the practical issues associated with building to zero carbon standards and as-built performance, but also understanding the speed of construction. And clearly the speed of construction is a real benefit for us we completed all 6 of our homes before any other houses were out of the ground on that site, and they were all started at the same time. The most recent homes we've done to the zero carbon standard meet the new London Plan zero carbon standard using SAP 10 as the methodology. So an air source heat pump and solar PV and our high performing fabric, and we adopt that high performing fabric as standard in all our homes. It's something we decided on when we first set out to start the business. We should have a higher fabric standard that meets the proposed 2021 fabric standards already. So that was one of the things, fabric first. But the 2 key technologies we think are going to be critical going forward are solar PV and air source heat pumps. And it's one of those, I think people are relatively familiar with it with solar PV, but air source heat pumps a little bit less so. And from our experience of building homes and seeing how they performed, a real lesson for us was around how do we redesign our house types for the use of heat pumps. So we've now redesigned our ground floors so they're much more suitable for air source heat pumps, and all our homes will have the same plumbing and wiring network to accommodate heat pumps. So designed for lower flow temperatures, so that's larger radiators, but also larger pipes which have bigger bend radiuses. Having options around where you locate the air source heat pump, the external units. Some clients don't want it at the front of the house and prefer it in the garden. Some clients would rather it be at the front for easier maintenance. But a critical aspect, particularly in a lot of new build homes, is having space for a hot water cylinder and having that located close to the external unit. So we've redesigned the house to enable that to happen. And I think we're still at the start of our journey. And I think one of the key things that I've learned coming from construction into the manufacturing world is the need for continuous improvement. And the role that continuous improvement can play in manufacturing, learning from sites, learning from the manufacturing processes and getting that continuous feedback to develop better and better products. That's what's transformed other sectors, and I think that's what will give MMC and manufactured homes the advantage over traditional homes as we progress and go forward. So that was it. Thanks, Joey. Back over to you.
Fantastic. Thanks very much, Nigel. Really interesting to see actually some of the impacts, some of the practical impacts of redesigning homes around a net zero agenda and what that actually means for how you look at layouts, where you put the kit, etc. Things like that. Maybe we can touch back on that in the Q&A. For now, I'm going to pass on to Scott Crease, the residential leader at the Building Services Engineer Max Fordham. And I think one of the things Scott's indicated he can talk about is how buildings are going to start to need to think really hard about a full life carbon, not just embodied energy or operational carbon, but how all of those things play together, particularly in a world where your operational carbon is reducing. So therefore, the impact of embodied carbon becomes much more significant. So over to you, Scott.
Okay, thanks, Joe, for the introduction. So hopefully I'm going to hit all of those points, and hopefully you can see a quick few slides that I've got on my screen. So I'm a senior partner at Max Fordham. Come June, I've been there for 20 years, so we call that a lifer. Residential work, it picks up probably about a quarter to a third of our workload in any one year. It's been like that really from the start, from projects like Alexander Road there in the beginning, right the way up through to the Max Fordham House, which won, which was on the long list for RIBA House of the Year award. We're getting involved in houses of all sorts of scales, for individual single units to master plans to urban developments. And to be honest, the sort of urban block is probably our largest area, working for local authorities, housing associations, but also we've worked as well for some of the larger house builders. And also want to say is we've just come from doing our own webinar series called The Future of Housing Design, and all of those lot are available on our website. And along with that, I've just borrowed some of these slides from those presentations. So it's a good sustainable presentation because we're doing lots of recycling. So as I say, we work across the different scales of residential housing, looking at the environmental design and the building services engineering that goes into support that. And we've been doing a lot with Passive House recently at the moment. And one of the things that's you get to the grips of quite clearly is how the form heat loss factor plays about. Slightly different to the fabric energy efficiency that James mentioned at the beginning, but you can actually see how by reducing the exposed area of a building, changing its complexity, simplifying in some regards, can actually help you bring down that heat loss form factor, and also bring down the need to be able to the need for these big thick insulation lines, which will bring into play many of the different types of modern methods of construction. So as I say, the urban block is one of the typical schemes that we try and work with. This one here is Chobham Farm, completed in 2017. Quite a standard brief, hit the London plan, 35% less than current building regs. So in some respects, that's quite akin to the future home standards that will be coming in across the nation. But what we're seeing is, that's a typical energy demand from production, from actual metered data that are in there. However, that's significantly more than what the SAP calcs would tell you. Compare that to Agar Grove, which has been completed, or certainly phase 1A of this has been completed in 2018. Which has been, its client was London Borough of Camden. It was designed to Passive House standards. There's also the NLA overall winner and sustainability winner and residential project in 2019, and it was also awarded CIBSE's Building Performance of the Year Award 2020 in the residential category. And this was built from Passive House, built and delivered as Passive House. We made the decision to go Passive House, sort of old school Reaper Stage C in 2013. So that's how long this has been in the making. But it did mean a lot of things were in train in terms about how the design had progressed. And we had to make that building work very, very hard to get to that standard, almost harder than it would have needed to be done had we made that decision to go down the Passive House route earlier. One of the key things in this was we did a lot of analysis actually at the distribution losses of wet space heating systems. The London plan requirement was that we followed a communal wet system, so we had to swallow that. I think it's 13 kilowatts hours per meter squared per year, shown there in the yellow bar, within into the Passive House design. Then we went on to do Max's house. So this is, in some respects, his retirement project, although I don't think Max would ever retire. Which he made that decision, well, many years before he even started thinking about delivering it as a project. So he's used many of the techniques that he's been teaching us in the practice, and we've been employing onto our projects: MVHR, warm air heating, use of an air source heat pump, PVs generating, and you can see that we've nearly half the performance of what the Agar project delivered, and really increased up the proportional PV generation into that as a single home. And I think that really stands testament to the importance of making those decisions early and making key decisions within building fabric, engineering systems to help you get towards these very low energy levels. Also mentioned in the introduction is the commentary about electricity, and actually the decarbonisation of electricity is very key to the government's goals for achieving energy efficiency and achieving the net zero targets. I mean, the SAP data that we're using at the moment is already out of date, and it was due. But you can also see that we've already surpassed the performance of natural gas, and even with any hydrogen injection, it's only going to work down there. However, the big issue is the cost of electricity compared to the current cost of gas. And even when you factor in the coefficient of performance or the leveraging of the heat pump cycle of things like air source heat pumps and water source heat pumps and the like, there's still a difference in fuel costs for heat. So it makes it even more important to actually drive down the base energy demand for space heating and domestic hot water before the things. You've got to ask yourself the question, is the how do you change this imbalance? Well, I think what is it, Sir Humphrey Appleby from Yes Minister would probably describe it as a courageous decision for any politician to try and adjust the cost prices of electricity in there. But it's going to have to happen if we're going to actually make the change for reaching net zero carbon, and also for promoting the switch to electric within individual homes and private homes outside of those bits and pieces. So I think that was pretty much all my slides. Some of the ideas are available from our that housing webinar series I mentioned, which you can get from our website. So really, back over to Joey.
Thanks very much, Scott. That's brilliant. And I mean, that was very interesting there to see how the impact of early decisions played out, and particularly over power sources, etc. How that's kind of crucial to the performance you can deliver by the end of the project. Okay, for the final presentation now, before we go over to the Q&A, I'm going to pass over to Marion Bailey, who's partner of PDP London. I think she's going to talk about some of the ways the industry needs to improve training and skills so that actually we're able to deliver on the promise set out in the Future Home Standard. So over to you, Marion.
Sorry, can you see my presentation? Yeah.
I can see the presentation. Yeah, that's great. I can't see you at the moment. If you want to put your webcam on.
Is that okay?
Perfect.
Okay. So good afternoon. So I'm from PDP London, as I've just been introduced. So I'm going to take you through a few slides. First of all, I'm not going to go back on the context of what we have to do here. I think it's been covered quite brilliantly by the previous speakers. The very first item that I'd like to perhaps dwell on a little bit is the brief, and making sure that if we want to achieve the carbon reduction that we are targeting ourselves to achieve, we absolutely need to empower everybody in a project to reach that goal with a very clear and very well articulated brief from the clients, the housing developer. And so there is perhaps quite a bit of work to be done on being very precise on that key document, which really sets the entire life of the project. And the more comprehensive the brief will be, and the more detailed and clear, the better the outcome will be. So that, I would say, for me, the very first step really comes from clients and the brief. Following this, obviously, we absolutely need to ensure that the design teams are absolutely ready to deliver on this brief. And I will dwell quite a lot on the fact that people need to retrain in the industry. It's true that, you know, I've trained myself 20 years ago, and low carbon design wasn't really on the cards, and electricity was definitely seen as the worst energy to heat our homes with at the time. So I think the industry has moved on, and we need to go back to the drawing board. There are some key documents that are absolutely crucial, critical, really, really helpful, such as, for example, this LETI Climate Emergency Design Guide. LETI, if you don't know, is a group of volunteers who have worked together to help the industry decarbonize. And this is an excellent starting point to embark in that low energy revolution in the construction industry. So I would urge you to have a look at this sets of documents which set some very clear, understandable targets. And for example, on new build, have set the target as 35 kilowatt-hour per meter square per year, instead of perhaps relying on calculations that are a little bit more obscure, relying on the concept of notional building, which is, we think, very unclear and not helpful in our target for decarbonizing the construction industry. So we need to start with very understandable target, not something that depends on a notional building that we compare performance against, but something that is real. So I would recommend that good read. The other really fundamental thing that we need to understand is we need to approach houses and construction in general, not really on an elemental basis, but as a whole house organism, I suppose. So it's a series of elements which, working together, will achieve that key target. So I'm putting here on the screen the 5 key principles of a passive house design, because I think while we might not always achieve passive house absolutely, it is based on building physics that are robust and sound and tested and proven repeatedly. So these are an absolute excellent sort of learning tool to be able to implement a low energy design. So I'd highly recommend, again, as a method to achieve low carbon, to use the passive house strategy. I would also stress on these 2 criteria, which are airtightness and core bridges, which are a little bit more tricky to understand for people who haven't yet embarked in the low carbon design. And I would say spend some time and to understand these building physics elements of a low carbon design, and get some consultant specialists on to help you with this. In particular for construction that are done in factories, modern method of construction is particularly important to detail these. It's often missed. This is another guide which is called the Easy Guide to Passive House Design. And there is a lot of literature out there to help you get to this low carbon design. So I would say there is no more excuse a few years ago, perhaps 5 years ago, it was a bit more difficult, but there is plenty of resources and training available to help us embark into that low energy design. So do it. I've just added, while I was listening to the others, this slide about retrofit, which is my speciality, and I've written a book about it. So I just wanted to put it a shameless plug here on this book. If you want to look into reducing by 80% carbon emission from existing, this book will give you 20 case studies of how to do that. Again, training is something we absolutely need to go back to the drawing board and our books and learn. And while it might be easier, I suppose, for a younger generation who don't know any other way, it's a little bit easier for older generation, but nevertheless, you can have a lot of fun learning and implementing. For example, on the right hand side, it's a workshop facilitated by ProClima on how to install airtightness tapes, and you can see that older generation are really enjoying themselves and learning these new ways of doing things. and building the house of the future with a very robust airtightness. So it is quite fun. Absolutely get your hand on a roll of tape and have a go. The other thing that I wanted to stress on is that it's important to do it en masse. We haven't got very much time to achieve the targets, as some of the previous speakers have mentioned. So in our offices, we trained a group of people. We're about 65 technical staff, and so we train about 15 people a year into these low carbon design. This is the only way that you really can make a difference. You need to train a group so that they can together help each other to embark in that new learning journey and exchange findings and thoughts and expertise. And then I would like to talk just on the main contractor's role also. Once we've tackled the issue of the lack of knowledge of the design team and also the trades, we need to make sure that the main contractors are also on board with us and have appropriate champions on site to be able to inspect, support and assist the trades and the teams overall to deliver a building that will actually achieve what it has set out to do. And no matter, for example, this is a straw bale building, but perhaps it might not happen too often, but no matter what the brief is throwing at us, we need to be able to understand the parameter of the building physics that will make a net zero target achievable. And lastly, what's will guarantee the success of your project is your communication with the end user and making sure that the operation of a low carbon house is made absolutely clear. And I don't know if you know anybody who has a new build house with an MVHR who have not changed their filters in the 4 years they've been living in their houses, but I have met a few, and that scares the hell out of me because you're meant to change it more like every 3 months at the beginning, 6 months while the house has been operated for a year or over. So it's really important to make some documents that are really, really clear to ensure there is no performance gap between what you set yourself out to design and how the occupant actually uses this building. And perhaps finally, publish your success stories, monitor the performance of your building and shout out about it and just say how wonderful and how easy perhaps the learning curve has been. So I'd really encourage you to to communicate on your experiences. Thank you.
Fantastic. Thanks very much indeed for that, Marion. That's absolutely fascinating stuff on issues around the performance gap and the difficulties of the industry and its current structures actually being able to deliver on this stuff, and also I guess questions about what the target that we actually should be aiming for is, and whether what we've got is really too complex to get to where we need to get to. Okay, can I ask the rest of the panel to turn their webcams back on as we open it up to questions from? I've got a lot of questions come through. We haven't got too long, I'm afraid. We've got about just under 15 minutes. I'm going to kick it off, I think, by I guess bringing it back to the topic at the top of the presentation, but asking it in a different way. And maybe Nigel, I could draw you in first, and the others contribute if you want to. I mean, how difficult is it, to put it in another way, to get the fabric energy efficiency that we're going to need from new build homes if you use traditional building techniques as opposed to modern methods of construction? I mean, is it possible to do?
It is possible to do. I think, as James pointed out, you'll need a thicker wall construction to achieve a 0.18 U value, which is proposed in the future homes in the 2021 standards. For us, that's about a 270 mil thick wall, but for a traditional build up, that's probably looking at near a 350 mil, so it's adding sort of 75, 80 mil to the structure. So that does make it more challenging. And I think the other challenge you've got is it pushes you towards products which are harder to install well. So mineral wool is easier to install well in a cavity than a solid board, because it's harder to get those boards to butt up as well in a cavity. So I think there's some performance gap challenges that actually pushing traditional to a higher standard may not actually deliver that much better actual performance as well. So I think the combination of higher standards but also monitoring actual performance is probably the combination we need, and the regs don't seem to be wanting to push that, certainly in the 2021 standards. Hopefully that will come in the 2025 standards. So it's not impossible. I mean, there's passive houses that have been built with traditional construction methodology, so it can be done. I think it's easier to do in volumetric or panelized systems, because you can get the insulation, some of the insulation in the frame, in that structural framing zone. So it's easier to achieve, and certainly in a manufacturing environment, it's much easier to get the quality controls. So for us, having quality controls and quality checks every stage down a production line is very different to the ability to get good quality control on every plot, on every site across the country. So there's some of the big differences, I think. James,
what's your take on that?
Yeah, I mean, I'd very much echo many of the things that Nigel is saying there. I mean, theoretically, it is achievable, but you do have the penalty of this, extra thick wall construction, which has implications on footings and lintels and other areas of the construction. And I would also echo the fact that, in a controlled factory environment, companies like Ilke Homes have that ability to really closely monitor and check the quality of installation. And so I think for those reasons, as well as in fact the high embodied carbon that we have in traditional masonry, brick and block, it very much would suggest that framed construction, steel and timber frame construction with EWI systems on the outside are going to be far the most efficient in terms of wall footprint, embodied carbon, and also in terms of reducing that performance gap.
Fantastic. Anyone else want to come in on that? Okay. Well, if not for the moment, I'll move it on to. We've had a number of people have raised the issue of the performance gap, and I've had a number of questions in kind of related to this. I mean, given the way that the Future Home Standard has been set out and the current upgrade to Part L has been set out, and given the state of the industry, how easy is it going to be to ensure that this whole drive isn't just completely undermined by a significant performance gap? Maybe Marion, could you comment on that?
Well, I'd say use a design method that avoids performance gap. So as Scott has illustrated also on his project, I think Passive House is based fundamentally on a no performance gap principle. So it says what it does what it says on the tin. If you design following the principles, you will be within a range of 15 kilowatt-hour per meter square per year, plus or minus, but the occupant activity will not really vary the operation vastly. This is really the base of the concept. So if you want to avoid performance gap, follow the principle of Passive House, which is based on building physics and tangible calculations and robust detailing, which is not able. If you just follow what the building regs tell you, you will not achieve a building that avoids performance gap. That's my experience. Scott, perhaps you might want to jump in.
Yeah. Okay.
Yeah.
Well, one of the things that is going to come through from the New London plan is the next tier of the energy hierarchy of the Be Seen. So it's not just be lean, be green, be clean, it's be seen as well. So there's going to be a requirement to publish your energy performance as for the buildings, and I think unless you really take that element seriously, there's going to be some embarrassment out there, and some retrospective offset payments, because if you talk to Gwilym, who leads our Passive House work at Max Fordham's, he'll say that one of the principles of Passive House is publishing your data. And it tends to be that one, and actually going down the full certification process, which lots of people back away from. That's where they see the additional cost of those types of schemes coming through. So, as I say, if you can make a decision early on and the client stands up and says, right, we're going to do this, that's the best experience of a way to actually close down the performance gap. If you put it front and center of the briefing process, you've got your best chance.
Does government need to move to, as Marion mentioned in her presentation, to just a simple per square foot emissions standard or something like that, rather than the complicated SAP-based notional models that we have at the moment? Would that help limit some of this? Nigel? Oh, sorry, Scott, actually, probably.
No, I was gonna pass that through. I mean, I'd quite like to see the it linked back towards actual consumption. If you're, rather than, if you're going on to sell a house, what has the energy cost been in the last 3-4 years? Be quite powerful. I don't think there's enough houses available on the market to make that element at the moment be the driver.
Okay, one of the other questions or themes that have come through in a number of the questions that I've got here is questions around cost of doing this stuff via modern methods versus traditional build techniques. And maybe Joe, as well as Nigel, I could bring you in here. What's your experience of how this compares, not only with the ability to deliver on the low carbon target, but actually to build to a budget and build to a reasonable cost comparable with traditional build? Joe, maybe you want to start on that, as you're using MMC on retrofit projects.
Well, obviously we would insulate a design build to an existing building, so we wouldn't actually get involved in the cost of the existing structure, but the speed of application has got to make a difference. What Elka Homes are doing is creating houses extremely quickly with the right methods, using the right systems, and that's got to make a massive difference in terms of cost saving. I think Nigel will have better information on that.
Yeah, I think.
Yeah, do you want to pick that up?
Yeah, so there's certainly, can it be done cost effectively? Yes. Is MMC more expensive? It can be as well. It's definitely more expensive to set up a factory and get that operating. But as you get to scale, those costs dilute, and the benefits of that continuous improvement also start to come through, and we're really seeing that now. I think the other aspect around offsite construction is there's a shortage of labour, and those labour prices have been going up. That's particularly acute in some parts of the country, not just in London and the southeast, but also some rural sites. And that really does have a real benefit around, if we're trying to continue to build more homes, we need to, in my view, we need to carry on building traditional homes at the scale we are, and then build more on top and add extra capacity from modular. But what I think modular can add is really pushing the envelope of what can be done on zero carbon, and doing that sooner, and really trying to get a step change in some of the quality that you see. And at the moment, how that's priced is difficult to assess. So we build to a higher fabric standard as standard. We won't build to a lower standard, but that's in our standard pricing against competing someone who doesn't build to that standard. As the regs improve, I think that will help also rebalance some of it, where there have been some cost increases in. That will probably rebalance off in those areas where it's less competitive.
Fantastic. Thanks very much, Nigel. I'm afraid we're running out of time, so I'm just going to very quickly ask one of the other questions that's come through, which is about how we use this agenda to promote a circular economy, and then we're going to have to wrap up. I don't know, Marion, if you had any views on that, or James, from a kind of supply chain perspective.
James, do you want to have a go?
Yeah. So yeah. I mean, I absolutely do. Yeah, have some thoughts on that. And I mentioned use of things like EPDs to understand, product kind of sustainability and life cycle, and You know, rock wool as a stone wool material is infinitely recyclable. So I think in terms of its kind of long-term sustainability, that's something that we're really proud of, that we think can really help towards you know, pushing this sort of, you know, net zero agenda.
Fantastic. Marianne?
Yeah, I mean, I think we need to embrace so much all at once. Circular economy is definitely in the construction industry one of them, and I would say let's yeah. Again, it's all a matter of literacy and making sure that we all know what we're doing. So we all need to be able to go and get trained and ask the right questions to the right people. So we need to each of us, yeah, just retrain and understand not just what is at stake, but how we can make a difference. Yeah, that's what I would say.
And no, that's great. And I suppose just finally to put that to you as well, Scott, I guess your comments around embodied carbon are relevant there if you're to a debate about reusing materials rather than just recycling.
I think reuse and recycling is very important, but it's probably not the most important thing right now. Now is getting all of that energy usage down. I mean, I've been pushing an agenda of less is more. So actually, let's think about, can we just get the volume of stuff that we use down, and by doing that you get all the benefits of reduced embodied carbon, the cost savings in doing that. So I think, you know, if you can start by using less, then we can then look at the exact way of how we can turn that around and recycle going forwards. I know there's some very good stuff that they're doing in the Netherlands around brick reuse, cutting down panels or making brick out of demolished brick. Those sorts of things I think will help in the, you know, the circular economy state.
Perfect. Okay.
Sorry, I just wanted to add one tiny thing at the end. We need to absolutely make sure that we're not just building to compliance because we can get away with it and then create a problem of having to retrofit this stock in just 10 years. So we need to make sure that whatever we build right now is really durable for the long term.
Great place to end it. Thanks everybody for your contributions. I think everyone will have learned a lot from that, and fantastic to have a discussion on this important issue. So yeah, thanks very much. We'll call it to a close there.
Thank you.
That's brilliant.
Thanks very much.
Cheers, thank you.